Hi everyone, you're always committed, and today we're going to run panel discussion about databases. My name is Denis Resnik and I will moderate the discussion. If you have any questions during the discussion, please put them here at theslider.com with the following hashtag. And now I would like to ask the participants to introduce themselves. Let's start.
So, my name is Denis Torres. I'm a Brazilian from and living in Malta. I'm a data platform MVP. I work with database since SQL Server 6.5, and uh, I moved to Europe only a few years ago, and I'm still adapting on the European community.
Thank you, Dennis.
I'm
Bruce.
Bruce Momjian. I live in Philadelphia, United States. I am a Postgres core team member, been involved with Postgres for 24 years, and I'm currently employed by Enterprise DB.
Thank you, Bruce. Vadim.
Hello everybody, my name is Vadim Tkachenko. I'm CTO at Percona, and Percona is company we provide software and services for MySQL and other database technologies. And we founded Percona 14 years ago, and I have experience with MySQL over 20 years. And in Percona, as a CTO, I'm focusing on database technology, what we bring into company, and what technology we work with.
Thank you. Radu.
Hi guys, my name is Radu Vunvulea, working as Group Head of Cloud Delivery inside Endava. Microsoft Azure MVP for around 8 years, or 9, something like that. And also Microsoft Regional Director, playing with SQL and NoSQL solution for a while, especially when you need to decide if you would go with SQL or with NoSQL. Thanks.
Thank you. So let's start with our first question. What is your favorite database engine and what you love particularly about it?
Well, the easy answer is that my favorite database engine is SQL Server, and I got in love with SQL Server since early versions, especially when version 7 was released, and SQL Server offered all the tools we need to work with the entire data architecture. We could create a production database, we could work with CTL, we could create a data warehouse, make data marts with a cube tool, the analysis services, and so on. So we had everything available, and this is the best thing that I like about this. But nowadays, this question is a bit more tricky when the answer is SQL Server, because SQL Server is transforming itself. The core technologies that form SQL Server now they can be found in other products. For example, Synapse Analytics is based on SQL Server. Is based on SQL Server beside many other features. And SQL Server 2019 has SQL Server Big Data, which is based on SQL Server, but is so different than a regular SQL Server that we can consider something different. Analysis services were introduced inside Power BI. Part of the analysis services were introduced inside Power BI. Power BI has the same engine than analysis services. So today we don't talk too much about we don't talk SQL Server. In fact, user groups have this challenge. User groups that were SQL Server user groups are transforming themselves and becoming Microsoft Data Platform user groups. because now the core of the technologies are involving many different products and not a single one.
So you like this infrastructure around SQL Server most? Yeah?
Exactly.
Great. Thank you, Dennis. Go on to the next. Bruce, maybe you?
Right. So obviously, my favorite's going to be Postgres. Having worked out with it for so many years, and of course, I think its two big strengths are the fact that it has an open source community. So just like Linux was able to dominate the operating, and FreeBSD were able to dominate the operating system space, we think eventually Postgres, being open source community, will pretty much do the same. I think the favorite feature of Postgres is extensibility, and that's allowed us to add things like GIS, full text search, NoSQL, data analytics very easily into the database without having to sort of rip it apart and put it back together, which is typically what you have to do to change a monolithic database. Postgres was designed to be extensible when it was originally developed in 1986 at a university, and that extensibility continues to be useful today.
Thank you. That's very interesting. Vadim?
All right, well, and obviously for me, like I said, I have over 20 years experience with MySQL. MySQL has been my favorite database of choice, and there is multiple reasons. And being open source is also quite significant of them. Now, I would say MySQL does not have as such community as Postgres, and one of the reason Oracle, which we will talk later, but it's still open source database which you can play with yourself. You can deploy bug fixes. You can deploy new features, and that I think we in Percona, and I will talk a little bit of Percona during this time. And I don't mean to poach Percona products or trying to sell. Our Percona products is also open source and freely available for everybody. But in Percona, we also build a clustering technology over MySQL, like Percona DB cluster, which you can take multiple MySQL nodes and they work in sync together. And with all this, my favorite topic is, of course, performance. I am participated in a high performance MySQL book, a couple editions. So MySQL and the performance around it, that's my my favorite topic.
Thank you. Thank you, Vadim. I would like to extend these topics a bit. So MySQL and Postgres are open source databases, and both have big infrastructure and community around them. But there is a point, one more point of view here, that when people come to this open source world from MySQL or Oracle database, and you need to choose what storage engine will you choose for MySQL, which plugins will you choose for Postgres, maybe you will use another storage engine. And this brings a big complexity. What do you think about this? Is it really too complex to choose the correct tools for you or not?
I think it depends what.
Go ahead,
Please,
Bruce,
Vadim.
sorry.
I think
No,
I think it really depends.
I wanted to say we did not introduce Radu yet.
Why?
So,
We did. I am pretty sure. But okay.
right, sorry, Bruce, go ahead.
So Bruce.
I think it depends what layer the extendability or the plugin is being offered. So we've looked at the MySQL plugin storage engine concept, but most of that's really a plugin that happens at the bottom of the database, really as it interacts with the storage, right? Typically, if you're using MyISAM or InnoDB or something sophisticated at the storage edge. So that's at the bottom. I think the part of the complexity when you put the extendability at the bottom is that you get different performance behaviors, you get different durability guarantees, and it's hard to understand exactly how transactions work when you're doing a multi-table transaction and some tables are durable and some of them aren't, and right that gets a little complicated. The Postgres extendability typically has been at the upper layer, so at the data type layer, at the index layer, at the function layer, and that extendability, whether it's for GIX, full text search, NoSQL, or data warehouse, actually works really well. And I think part of it is because it was designed that way, and part of it because the extendability is really happening at the layer the user interacts with the database. So they're normally interacting with the database in terms of tables and functions and data types and so forth. And that is really where Postgres extendability shines. I think the MySQL idea of having the different storage engines has a performance benefit, and Postgres has tried to mimic some of that with unlogged tables and some other facilities. But I think the benefit of the MySQL layer at the bottom is for tuning performance for different storage engines. I think the value of extendability for Postgres at the top is really in usability and accessing new workloads.
But isn't it too complex for newcomers? What do you think?
So by default, the extensions aren't installed. So typically, actually take that back. You know what? I'll tell you a good example. Historically, when I've worked with databases, in fact, I even have a slide on this. Typically, when a database adds an extension or a feature, whether it's Informix or Oracle or even I don't know about Microsoft too well. Typically, it's kind of bolted on the side of the software. Okay, meaning it wasn't really designed to do that. It's sort of something you buy additionally. You kind of add on to it. And typically when you do that, bolting on the side, you end up with a whole host of problems. Transactions don't work the same, backups don't work the same, interaction between different features don't work the same, and you're ending up with this Frankenstein. I've talked about this a bazillion times. These Frankenstein monster where you got a head from one database and an arm from another, and it just kind of walks really awkwardly. And the Postgres system has not had that problem. I think partially because it was originally designed to be extendable, so the hooks were already there. The other I think key part is that Postgres itself, everything that we ship is designed using the same extendability layer. So when we define an integer in Postgres, when we define a function in Postgres, when we define an index type in Postgres, we're using the exact same extendability method that an extension would use. There isn't this is a special data type that uses underlying interface, and then the extension uses some other capability. That's not the way it works in Postgres. When you define an int, you literally are adding rows to system tables. For how wide is an int? What is the input function for an integer? What is the output function for an integer? So it's kind of annoying, actually, as a server developer. Every time I have to do something, I've got to use that interface. But because that interface is so clean, we have the ability to add things like full text search, GIS, and NoSQL, and they're just the same. You can't identify, once you install something or you start using some of these new features, they don't look any different. They appear the same, they behave the same, they back up the same, they have the same transaction semantics, they have the same performance characteristic. There's nothing sort of special about an extension versus the built-in types. And I think that's one of the secrets of why that sort of complexity problem has been avoided for extensions. Normally, you're right. Extensions with databases is a bad thing, and I've had to fight against that sometimes when people are coming like, well, I've had bad experience with extensions with other databases. I don't want to go there. I just want to use the core engine. And you can do that, but effectively, we ship with full text search installed. We ship with NoSQL installed. We ship with data warehouse installed. I guess GIS is an additional thing. You got to compile. You have to install it. But again, in most cases, it we've been disciplined about it. I think that I think eliminates a lot of those problems.
Thank you. That
Yeah,
sounds
I would
great.
like to add
Vadim?
on MySQL side, if I can. So on MySQL side, you indeed you can use other storage engines, but by default it comes now. You can say with one choice, InnoDB, and really, if you just install MySQL, it just should work out of box. And there are other storage engines, but I think you will find about them only when you understand more about MySQL and more about your technical requirements. So I would not say other storage engines is a problem for MySQL. Where it can be indeed overwhelming for users, and it is in operational state. How do you take backup? How do you set up replication? How you do failover in case of a replication? How you ensure high availability of MySQL deployments? And this is where new user indeed, I think, can be lost. But internet is full of resources for especially for MySQL. I believe you can find help online and applying a little bit of time and effort. And there are also a wide variety of experts which you can ask help for. So I don't think MySQL has major barriers for entry for new users.
Okay, thank you. So your idea is just to use the default installation, default storage engine, and then if something will not satisfy you, you will look for the extensions or replacements.
Yes, you committed the time to understand your environment and your requirements. You can extend and expand your installation.
Okay, thank you. Radu, what is your favorite database and what do you particularly love about it?
Well, to tell the truth, around 2015, I really loved Azure Tables. It's a very basic NoSQL solution, but why I really love it and I think it's very powerful in specific cases, it was because it was very cheap and the performance was amazing, and it is still amazing. Nowadays, one of my favorite storage solutions I'm using, especially for NoSQL cases, is Azure Cosmos DB, because in most of the cases I'm working on projects that are based on Azure and Microsoft technologies. And what is the beauty of here is that you can allow data with a table API, with a MongoDB, or for example with Cassandra API. And why this is very nice is because depending on the team shape, you might have Java developers in the team, or .NET or Python and so on. They will have different flavors. They would have specific preferences. And not only this, but depending on the industry where you are active, you will also see preferences of what is the technology and database stack. So in the most of the cases, I prefer to go with Cosmos DB with different APIs depending on the needs.
Well, that's pretty interesting topic. You know, when Cosmos DB was announced, it looks like it will be like a killer for on-premise solution SQL Server. And year over year, Cosmos DB take new load, new products, new features. But what do you think about this? Can Cosmos DB really replace relational database?
No, as I don't think that in the near future we will see the NoSQL solutions replacing relational databases. There are two different things with different purpose of it, and depending on what you're doing, you might fit in one type or another. But even so, once you identify what are the features that you're looking for and so on, especially for complex scenario, then it's pretty clear which one best suits you. And also another thing that I'll think at the beginning is that a NoSQL solution, it would be much cheaper than a relational database solution. This might be from the licensing point of view initially, but once you start to look at the computation power that is required to do the same queries and so on, you'll see that price is the major factor or the major differential factor that you should take into account at the moment in time when you decide to go, for example, with Oracle or SQL Server versus Mongo, versus, for example, going with MongoDB or Cassandra DB. Because in the end, the computation power that you need behind the scene will be very similar for the same queries that you would run.
Okay. Are there any clear scenarios when I should choose relational database or Cosmos DB?
Usually, they're depending on, for example, how many indexes you need, depending on how does the queries look like, and if you can design the database in such a way where even if you would duplicate the data that you are querying, it is in the same collections, are in the same documents, objects, then you might go with the NoSQL Cosmos DB. You jump and you have, for example, you have inner joins and you have query that goes across multiple tables, multiple objects. Then you might look more closer to a relational database.
Okay, thank you.
I would like to
Yeah,
make some
Dennis.
comments. I agree very much with everything that Radu explained, and I would like to include some point of views. What's happening in the market is that on a very recent past, we were used to put all kinds of data inside a relational database. And we are discovering that the relational database is not the best kind of tool for all kinds of data. For example, not mentioning CosmoDB now, many companies are also already realizing that logs, for example, logs about what is happening in the system, what the user is accessing, and so on. The database is not the best place for logs. They can put in unstructured storage. Uh, in the cloud, in this case, we would use blob storage to store logs, and then we would have many tools to access those logs without putting more heavy storage over the relational data. So we are discovering pieces of data that should be put outside SQL Server. And one of these situations are the situations where we need unstructured data, a data that doesn't have a fixed structure, and CosmoDB can achieve that, and a global coverage. CosmoDB can achieve global coverage by having great performance, but by reducing the level of the trust on the transaction. So for many scenarios, we don't need a high level of trust on the transaction. We just need the data to arrive at some point. But it doesn't need the order the data will arrive sometimes doesn't matter. So we can put this data on CosmoDB, but the data for which we still need heavy transaction control, we will need the relational database. Uh, Let me put one link on the chat. I'm not sure if you have attended. If someone have attended as well, you could comment. This in relation to the sessions I attended about CosmoDB, this link that I just put in the chat is the best session, CosmoDB session that I ever attended. It was made by Dr. Rema Nime on PASS Summit 2017. She explained how CosmoDB is able to achieve a global coverage and the transactions levels of CosmoDB and so on. It's very interesting. It's the best CosmoDB session I ever attended.
Yeah, that's a great session.
And yeah, were there?
Yeah.
Were you there? Yeah. It was a great session. And just to put some interesting questions to Edu, um, I don't know too much about CosmoDB. I don't know deeper about CosmoDB, but I have the feeling that when the company decides to go to the CosmoDB because it needs the global coverage and the data fits on the CosmoDB format, I have the feeling that the company needs to be more prepared for what comes next. The BI solution that will come after that. Because many companies don't make this kind of preparation and counts with the ability to make selects over the data and just extract the data, sometimes directly from production. But with the CosmoDB modeling, this is not so easy. Maybe the company will really need a formal ETL system to convert the data for a BI system later. Not that other companies should avoid this, but there are many companies work around this, making small queries directly on production. And in CosmoDB, this would be way more difficult. They need a more formal structure. Could you talk more about this, Radu? Am I correct about this assumption, or am I wrong about this assumption?
Well, depending what kind of ETL solution you are using. So there are some things that, for example, one of the things that you can do is if you have a connector on the ETL that you're planning to do that has a connector or plugin to Cosmos DB, then you can use it without any kind of issues. What I've seen is that the blocker itself, it's not the ETL itself. It's, for example, if we're talking about a migration, and we could go a little bit more generic than talking about Cosmos. It can be migration for an organization that is using, let's say, SQL Server on-prem or Azure SQL or something similar, and they're planning to migrate to a non-SQL solution, might be Azure Cosmos DB. Now, the biggest problem is that not all the features might be one-to-one. And because of this, might be more issues related to compliancy than integrating them to an ETL like that. Just to give you a simple example, one of the things that we are missing at this moment in time, but future might add these kind of features, would be, for example, inside Azure Cosmos DB, to create a backup snapshot in any time you want. There are organizations that are coming from SQL Server, and they have these kind of things as is required. For example, every 24 hours, the specific time interval that they want to take a snapshot. But this was just an example. There are a lot of small things like this, and in the moment when you do the migration, you need to identify exactly how you can match all of these things. What are flexible or what or laws that they need to respect. For example, if you're talking about the SSIS and plugins that you could use with Azure Data, in this kind of situation, you have a connector for Cosmos DB, so you can start to crunch data and so on. One other thing that I see on ETL or for NoSQL solution like Cosmos DB is that some of the flows that are covered on the ETL are more on data analytics part. And then you need to have different tools and maybe even different services from a cloud vendor that provide to you to be able to do that specific thing.
Thank you. That's pretty interesting that we've talked about that session from Rimaneme on past summit. Because of that session, I realized that Microsoft is coming to cloud and databases in the cloud seriously. Yeah, and now we have a lot of offers. We have Cosmos DB, we have SQL Server, we have Postgres, MySQL, we have platform as a services offers from Microsoft Azure for all these three databases. We have Amazon Aurora for Postgres and MySQL, Amazon RDS, and we have even more choices in the cloud than on-premise. Yes? What do you think about future of cloud and on-premises databases? Will on-premises databases survive in the next decade? Or everything will be in the cloud in 2030?
Well, I can comment something about this. And the interesting is the way the question is made. On-premise or cloud? Are we staying on-premise or are we going to on cloud? It seems like a game and we need to choose a thing. And when a scenario like this happens, Microsoft is a specialist to change the game rules. It appears with something new and completely change the rules. And that's what Microsoft did. We were thinking about, will we continue on-premise or we will go to cloud? Then Microsoft launches Azure Arc, ARC. Azure Arc enables us to install and manage PaaS services in any environment, like Azure Anywhere, SQL Anywhere. We can get the cloud service, which is a platform as a service, and install on-premise. We can have the cloud on-premise. In this situation, are we using cloud or are we using on-premise or both? Or are we mixing both? So Microsoft just changed the game totally. And we can integrate on-premise servers in the cloud and manage the entire on-premise and cloud environment as a single environment. So we were thinking about this question, on-premise will survive or will we go to the cloud? And suddenly Microsoft changed the game. On-premise and cloud can be the same thing. It's your decision. You can use your hardware and still integrate your hardware inside the cloud environment. Your hardware will be part of your cloud using PaaS services. So the question is different because the on-premise will go to the cloud, but will continue on-premise at the same time. There is this possibility. So companies that already bought hardware, heavy hardware with some capacity, will do what? Will add this capacity in the middle of the cloud environment, and for some purpose will be provisioning virtual machines or services using the hardware that is on premise, and will be almost transparent using the new Azure Arc. So when we come with a decision like that since the game is set and we have the sides to decide, Microsoft just came and changed the game.
Okay, thank you. That's very interesting
Well,
point.
let me agree with somewhat with Dennis about that on-premise or cloud question. I think will become less relevant. I believe there will be on-premise deployment and there will be a lot of cloud deployments. But what clouds bring us, I would say, easy to use, one-click button or it's one command line, and you can deploy one instance of database, multiple instances of databases, and what I think what will happen, the same easy of use will come on. Now, I would not promote any specific solution from Microsoft, but I think currently I like to focus on open source solution and which available for everybody. And I think this is where Kubernetes actually makes a lot of significant headway. And in Percona, we work on database Kubernetes operator, which I name to bring cloud-like experience to your own data center. It does not have data center. It still can be in cloud, but you pretty much in control of your environment. You can easily deploy, scale, configure for high availability, and destroy your environment pretty much on demand. We are moving to kind of like a world without database administrator. I hope database administrators will not be too mad at me, but world will be more driven by developers, where developer can with a single command, with single click, install database instance that to be in cloud or on premise with no difference.
Thank you.
Well, I think that, Vadim, I think that you point something very, very important. So we started initially the discussion with the following assumption that one of them will win, on-premise or cloud. As you already know, we are already have things like edge to cloud and things like that. The globalization, because of the cost, because of the high availability that is required. Uh, I think that in most of the cases we will see a mix, and it's a mix between on-premise and let's talk about data. On-premise data that needs to be kept specifically in specific location, countries, and things like that. Very good examples for this kind are not only, for example, countries from CE, but also, for example, from Russia and China, where you have very strict rules and you cannot take outside that country specific data. And this will remain in the future. And things that are that can taken outside, you might prefer to go somebody in one of cloud provider or multiple ones, because why not? You can do it nowadays as long as you can support the transfer codes between different cloud vendors and so on. And the second discussion that I think that might be pretty interesting to talk about, if I'm allowed, is let's talk about microservices and Kubernetes. They are very powerful. They bring more cross-platform compatibility, different cloud vendors, different on-premise hosting solution, and so on. Let's talk about how and if makes sense to have your database hosted and running inside your Kubernetes cluster. And let's think about big database, not talking about the one that have 100 megabytes or 5 gigabytes. Let's talk about the one that have half a terabyte of data that you're storing. Does that make sense to run inside a Kubernetes cluster or any other orchestration solution versus having a virtual machine or a cluster where you are running your solution? Can be platform services like Cosmos DB, could be Azure SQL, could be anything else from on-prem. This is something that I find very interesting and something that future might shape it in one direction or in another.
Radu, looks like we lost you. Okay.
I'm back. Sorry.
No,
So
all is good now. Did you finish, or you have something else to add?
yeah, I was just trying to see also from the other colleagues what is their opinion about this, because personally I think that large database where performance is very important, we will not run inside some Docker images inside the Kubernetes cluster, at least for the next few years will be on a dedicated cluster or platform as a service from Azure or from AWS and so on.
Okay.
I mean, you're right
Well,
that
if
microservices.
I would like to
Bruce?
comment what Radu. Okay, go first, Vadim. Okay.
We
all right.
didn't
So,
hear Bruce's opinion on this topic.
So
all
I would
right.
like to comment a bit
It is some
about
kind of
what
delay here, but
Radu mentioned.
Okay,
Uh,
Dennis, let's give a word to Bruce. He wanted to share his
okay,
opinion on this topic. Thank you.
okay.
Bruce?
So I think for Postgres, we kind of let the cloud and container thing kind of fly by for a couple of years. And Radu, you're exactly right that our initial impression was that the whole cloud, particularly the container thing, was for microservices, where you can spin them up and not shut them down and move them around. And you're thinking, who's going to move around 500 gigabytes of data, right? It just doesn't make any sense. So effectively, what we identified were four different features that containers typically give you. One of them, obviously, is the ability to create and destroy them really easily, but not a whole lot of value there. Um, there's the ability to spin up additional ones, which actually has some scaling capabilities for Postgres. There's the ability to install multiple versions and stuff, which also probably isn't a huge value. But the big value we found with containers was deployment. That when you're talking one or two databases, deployment's not a huge deal. But if you're talking tens or hundreds of databases, particularly not only the databases, but the monitoring, the replication, the failover, right, the backup, all that stuff that's got to go with the database to make sure it runs well. Deploying all that at scale in the tens or hundreds becomes very error prone. So what we kind of realized only lately in the past couple of years is that three of the four things the cloud gives us not really that useful, but that deployment capability of automating a full stack database deployment with all of the sort of support stuff that needs to go around it, that's actually pretty useful. So you're kind of right. You're not going to spin them up and drop them down, but I think containers, particularly because they're very lightweight, they're not as heavyweight as a VM typically, are really kind of a good solution for containers. So we're seeing Postgres operators where you've got the base operator, which is the database, but then you've got another operator, which is the monitoring, another operator, which is the logging, or and then a backup one and a failover one, and that starts to make a lot of sense to ease deployments, and it starts to make deployments look as easy sometimes as they do on cloud, right? And of course, when we talk about cloud, what cloud are we talking about? Are we talking about private cloud? Are we talking about VMs like EC2 instances in a public cloud? Are we talking about a managed service like RDS or Azure Postgres? Or are we talking something that's closed source, which is a fork of software, like like Aurora, right? So you've got a huge span of choices. It's just not on-prem and cloud. There's on-prem bare metal, on-prem private, on-prem public, cloud, infrastructure as a service, and then database as a service, and then technically hybrid or advanced database as a service. And that that's just additional capabilities that you give customers. There's no question that the amount, and you were talking about DBAs, there's no question that the amount of staff required to run a typical relational database is really too high. Particularly, I'm looking at you, Oracle, right? Which has really hard tooling. Microsoft's somewhat better in terms of automating stuff and allowing administrators to efficiently do stuff. But still, there's probably just too much there. And when you add up the cost of having that staff sitting around waiting for a disaster, and you look at the cost of the cloud, you're kind of right. It doesn't make a whole lot of sense to have huge teams of database people. If I can, if and database is a small part of my company. Why would I do all of that work myself? And whether that's going to be containers in your private cloud, whether it's going to be containers in a public infrastructure cloud, or even a managed service, that's a tough question, and we see customers kind of all over the map on that one.
Thank you. Dennis, Vadim?
Yeah. Well, it's interesting. Radu was questioning about how containers would be useful for a relational database, and if they would be useful for a relational database. And I confess, when I started to see containers and studying containers, I had exactly the same questions. Would they be useful for a relational database? And I don't have an answer for this question yet. I'm not sure about that. But what happened in this time is that I discovered the launch of SQL Server Big Data Cluster. SQL Server Big Data Cluster is not a conventional database. To talk about a bit about his history, in the past, Microsoft created an on-premise solution. It was called PDW, Parallel Data Warehouse. It was very expensive. But what the solution was able to do was an MPP environment, a massive parallel processing over SQL. So we could send a SQL query to a node, and the SQL query would be broke down to be processed by many nodes, exactly as the MPP pattern that is used by Hadoop, Spark, and many other environments. This evolved to SQL Data Warehouse. Then SQL Data Warehouse evolved to Synapse Analytics, although it's not only a change of name, but it's a real evolution. And then we got big data clusters. What big data clusters have in relation to containers? Simple. Big data clusters is completely deployed inside containers. Is a big MPP environment deployed inside containers. And the storage is managed mapping from inside containers to outside environment, so the data is not never at risk that a pod goes down or something like that. And we have data pools, we have compute pools, and we can at any moment to add more pods to the pools. We couldn't do this in an on-premise environment, in a physical environment, and with virtual machines it would not be so easy as it is with big data clusters. So Microsoft managed to find a way to fit containers with SQL Server in an absolutely great way. That's the big data cluster. It's intended for managing big data and intelligence data, and processing massive amounts of data, allowing us to use all the containers features. We can provision a new pod and add more nodes to a data pool, add more nodes to a compute pool easily. So this is a great fit for database inside containers. Is a great way to use database inside containers. Bruce mentioned about the deployment. Yes, that's what we get from microservices. We get an easy deployment, the ability to be more agile, to deploy small pieces of an application, piece by piece, and so on. But I confess, I don't know for sure if this justifies SQL Server to be inside containers, because this kind of deployment pipeline could also be done with SQL Server in a virtual machine. A regular, let's say a regular SQL Server, I'm not sure what a regular SQL Server really gets from being inside containers. But MPP environment, which is the big data cluster created on SQL 2019, has an incredible fit to be inside containers. So Microsoft managed to find an incredible fit between containers and SQL Server using big data clusters.
Yeah, that's interesting. Big data clusters is probably some kind of edge case. Because, for example, when my clients ask me if they can use SQL Server in containers, I say no, not today, not these nearest years, but maybe in future, yes. And I have a feeling that Postgres and MySQL these days are much more ready than SQL Server for containers. I know that Vadim had something to tell about this. Yeah.
Yes, I would like to offer my perspective on containers. So I think container orchestrations platforms, Kubernetes, they bring this concept cattle versus pet servers. And if you treat your database as pet, if you have really one big monolithic database, you set up all your scripts around that database, you probably don't need Kubernetes and containers around that one single big database. You should be fine. But now, when we speaking about deployments at scale, what Bruce mentioned, when you need to deploy database on demand, and when you deploy database, you deploy automatic backup, automatic failover, automatic monitoring. You may deploy monitoring server. You deploy 10 of databases, and they all automatically comes into your monitoring system. This is where orchestration, container orchestration is very important, I believe. And of course, you can rely some big guys like Microsoft, Azure, or Amazon RDS will do that for you. But with open source product, we value freedom and the flexibility, and this is where we can offer you control over your databases, how you deploy that in containers.
Yeah, I completely agree. And now with this era of microservices and containers, it's open source databases, MySQL and Postgres really shines here because building the infrastructure with Oracle or MySQL with microservices, separate servers for databases will be a bit expensive. Yeah. So more and more people choose MySQL or Postgres for this. And I am very interested, Vadim, in this topic. Some years ago, Oracle bought Sun Microsystems and also MySQL as well. And that actually divides community into two different camps. What happened in your opinion? Was this a good move for MySQL, or this was some bad thing happened that days?
Yeah, definitely. And sorry, I have some talking points on this, so let me look into that. So definitely. So I don't remember exactly. It was like 10 years ago or 12 years ago, and MySQL was not in a good place at that time. And even Sun bought MySQL, and then Oracle bought Sun. There was a lot of uncertainty, and of course, you could hear a lot of opinions like Oracle will kill MySQL, Oracle will destroy MySQL. The community was divided. There other forks appeared. But I should say that prediction did not happen. But there is good stuff and bad stuff. So first, let's talk about good stuff. Good stuff. MySQL development is really continuing. We can see new MySQL releases. We can see new MySQL features. We can see new replication technology like group replication from MySQL. And releases happen pretty much regularly. And I would say the product is pretty much alive and striving. I have zero doubts in MySQL future and in Oracle commitments to continue MySQL development. But then, as we know about that tale about Scorpion and Frog, and Scorpion has its nature, Oracle is being Oracle, and frankly, I would expect more from companies that governs open source product. I would expect more involvement of a community and collaborations. What happens with Oracle? They pretty much develop that product in-house. We don't know when release will happen, what feature will be included in that release. They don't really accept a lot of outside contributions for a new feature. Say if we in Percona develop new feature and Oracle likes it, they will go and do and implement it in different way, in a little bit different than Percona. But they every so often accept our bug fixes. So I would say there is still a relation between Oracle and the community, but I would love to see it a much bigger extent than it is right now. But back to my first point, I do not worry about MySQL future at all. It will continue to be developed as product and continue to be available in the future.
Thank you. By the way, Vadim, you said that you are not, you don't worry about MySQL future, but what about Oracle future? You know, last year Oracle lost its biggest client, Amazon.
I really cannot comment it, not because I am under some legal obligation. I really did not look into Oracle database and Oracle Cloud. I think Oracle is doing a big push on Oracle Cloud. My opinion, my personal opinion, it is not very successful. But I think Oracle has a lot of resources to survive for a long time. So I would not worry about Oracle either.
Okay, thank you. Okay, Dennis, I have a question for you. So these days, probably starting from SQL 2012, Microsoft made this slide course to make a Swiss knife, SQL Server, Swiss knife from SQL Server. Microsoft included their graph database, column store database, in-memory tables, NoSQL solution, the JSON, and functions on functions, big data clusters, machine learning services, and everything. So, what do you think about this trend? Is it good for SQL Server or it's not? Because adding these new fancy features, new engines inside SQL Server, we're not getting too much SQL improvements and core relational things. Is this a good trend or not for SQL Server?
Each of these features have a different story about their lifetime and how they were created and why they were created. For example, Polybase is a very successful feature on this area, uh, and Polybase is the core for new technologies. Polybase is the core for Synapse Analytics and big data clusters. In the end, we may not use too much Polybase inside let's say a regular SQL Server, but the Polybase appeared on the engine and it turned it possible many incredible works inside Synapse and inside big data clusters. So it's not only about turning one single software SQL Server into a Swiss knife, but to turning the platform more complete. Sometimes one feature arrives in SQL Server, but it will be most deeply used on other softwares, such as Synapse and Big Data Cluster. Polybase is one example. ML services is another example. ML services inside SQL Server doesn't mean at all that we would be replacing the Azure ML. In fact, the ML services inside SQL Server evolved to a point that we can prepare the model inside Azure ML, and we can import this model from Azure ML to SQL Server. So the model will be executed close to the data, in a point close to the data. Or thinking about SQL Server on a development environment, a developer, a data scientist specialized in R has the ability to have a development environment using SQL Server and already executing their code close to the database. And this would be made more for a development environment than a production environment. On the production, this feature is deploying compiled models, not the source code, and running compiled models close to the data. Uh, so each feature has a history, and they are moving in the direction not of a single product, but an integrated platform. And this is interesting related to the motivations that created Synapse Analytics. Why Synapse Analytics was created? Many companies, many big companies, big customers from Microsoft complained that it was too difficult to manage a data platform because they had the need to put together many different tools, many different tools. They had the need to work with Data Factory, Spark, Databricks, SQL Data Warehouse. It's too much, and too much tools and too much knowledge they would need to manage, and things become very difficult to manage. And what Microsoft made with Synapse Analytics, Microsoft integrated all the tools. Synapse Analytics is capable to provide services as SQL Data Warehouse, Spark, and Spark cluster, provide services reading unstructured data. Data Factory is inside Synapse Analytics, and even Power BI is integrated with Synapse Analytics. So the idea is that these features will be integrated in a way to make easy the learning curve for these tools. Make this learning curve more easier. Some other features you mentioned in-memory database. I already saw in-memory database on the list of failed features. In-memory database arrived in a moment that we were in need of data ingestion, huge data ingestion, and the traditional relational format would not support that. So the in-memory were capable to make the ingestion, but it was very fast in the market that we moved to ingestion tools, open source tools like Kafka and Microsoft tools like Event Hub for data ingestion, and then the in-memory using inside SQL Server. It's possible, it's working. Microsoft is evolving it, but I already saw it as in lists of failed features.
Yeah,
I don't see
thank you.
JSON support. Yeah.
Yeah, this
Okay.
is the question
Uh,
particular about JSON support, and it's very interesting. Well, it's not a big secret that Postgres has bigger SQL capability than MS SQL, and I know that the MS SQL community would like to have some more features in T-SQL. But how Microsoft is listening to the community votes? Do you think uh, it's good enough reaction with releasing all these features to the community needs, or Microsoft is losing this community focus these days?
um, both things happen. Considering what happens inside Microsoft, both things can happen. Sometimes it loses focus on some features, sometimes it works on other features. But the point is, the JSON support, I don't see at all the JSON support as a NoSQL replacement or as a NoSQL database. I don't see it at all. What happens is that sometimes in middle of a relational database, you may have some data that don't have a fixed structure. You had before the XML support. Microsoft just changed the XML support, just added to the XML support the JSON support. We can choose between XML and JSON. And why it was done like that? Because we are using REST APIs a lot. And REST APIs are based on JSON. So SQL Server can produce immediately a result to be returned to a REST API, but not really with the intention to replace NoSQL database. I don't see so huge intention over this. The graph database is a mystery. Is a mystery about the graph database. I consider a mystery. Why they are
Yeah,
there?
but
They are there.
you provided a good idea previously why it's there, because we can do these graph operations close to the real data. Yeah, that was a pretty
Yeah,
good answer for me.
Yeah, I would suppose that the graph database was included to prevent some SQL users, some companies that are focused on using SQL, to have to test different products in order to solve a small problem. So maybe SQL Server can solve some small problems by itself using the graph database features, and prevent a company that is already using SQL Server to go seeking different products, searching different products. It could be everything together. But like I said, every one of these features have a different story. And the most successful features, the MLCS and the Polybase, they resulted not in turning SQL in a Swiss knife. They resulted in being the core for other evolutions that brought a bigger data platform like Synapse and big data cluster that came from Polybase.
Thank you. That was very interesting. Okay, and next question for everyone. You know, a long time ago, probably about 10 years, NoSQL was very trendy, and there was a lot of opinions, also from very famous and people, that NoSQL will kill SQL. There will be no relational databases soon. We will have just NoSQL everywhere. So 10 years passed, and this didn't happen. What do you think? Will it happen in next years, or everything will be like it is today?
Well, I don't see this as a competition at all. Um, uh, I see this as we are identifying the best tools for the data. Instead of putting everything inside a relational database and not everything were a fit for a relational database, we are identifying better what data should be in what tool. There are data that should be in a NoSQL database, uh, making a very good use of the global network of a NoSQL database like CosmoDB, and there are data that needs a very high integrity on the relational processing, and this can be achieved on a relational database like SQL Server. So I don't see as a competition. We are just break down the data in different kinds and putting them for the correct tools.
Okay, thank you.
So historically, relational systems have had competition. In the 90s, it was object databases, right, where you were going to take a whole object and throw it in the database. And then in the 2000s, it was XML databases. Obviously, Microsoft went down that road. But obviously, relational databases go back to the 70s. So we're, I guess, 50 years in here, 49, 48 years in. And the reason we're still here with relational databases is that effectively it's very easy for a relational database to subsume the features of a less sophisticated database. It's much harder for a less sophisticated database to subsume the features of a relational database. So effectively, relational databases have had challenges in the past. They've looked at what value are those challenges providing. And the smart relational databases have been able to modify themselves to adjust for NoSQL, to adjust for GIS, to adjust for processors, to adjust for data warehouse, to adjust for whatever, and sort of subsume those features into the database. The most recent example I'm thinking of is machine learning and AI. Historically, what happens in the database realm is a new technology comes out. The assumption is that we have to create a whole new architecture to handle this new technology. So we come up with a data warehouse style database, right? Or a JSON database or an AI database. And these are considered to be distinct from relational systems. But over time, in those past 50 years, what's happened is that the relational systems have looked at the value of those satellite applications and then subsume the features into their relational systems. Because if you think of the relational systems from the 80s and 90s, they did not have the features that they have today. So I think ultimately, NoSQL is just one of many, many challenges. Now, it is right. It is correct that something like log consumption, log file consumption, or a large network database, or something that needs to be geolocated, or massive scaling across multiple nodes. There are cases where that does make sense to keep in a separate system. But the question is that going to ever be the default way you do things. And I think what relational systems have shown over this time is that the most simple, user-friendly, flexible system is still the relational. And you use the other system when you have performance requirements, we have scaling requirements, where it just doesn't fit. I think a lot of people went into the NoSQL thinking, oh, everything's gonna be simple, everything's gonna be simple queries and stuff, and after a while you're like, my application's gonna change, I'm gonna need reports, and most people are not using NoSQL for multiple nodes. So if you're not scaling for multiple nodes, why did you throw away 90% of your features for in most cases a slower database? Postgres is faster on a single node than Mongo is. So Mongo's great if you're going to use multiple nodes. Well, 95% of people aren't doing that. So why are they throwing away so many usability features to use Mongo? I guess it looked good on the resume, maybe. I don't know. But this is probably gonna be the evolution. The XML databases are still around. The object databases are still around, but again, as relational systems subsume their features, they kind of shrink. And I think that's the same thing's going to happen here. They're never going to disappear, though.
Thank you. I think that Mongo can be fast if we will not use durability. Yeah, if we flash data once per minute, but that's not a good choice as database.
You can turn off durability in Postgres, so.
Oh, so there is no choice again. Just Postgres. Okay. Vadim?
I will probably, I am probably old school, and I am with Bruce, and I think relational databases are fundamental now to computer science, pretty much as TPCC protocol, and they not going anywhere anytime soon. And yeah, there indeed a place for NoSQL databases. I can see them. Some already mentioned unstructured data or massive horizontal scaling. But what also I see NoSQL databases, particularly MongoDB, they are trying actually to add, and I would say not very successfully, now relational database feature like transactional, like MongoDB is trying to add left join operations, or if you look in MongoDB, they have this aggregation pipeline, which really just, for me, a very hackish way to implement a window function and analytical function in MongoDB. So they're trying to catch up. But what made NoSQL and MongoDB successful, in my opinion, again, very friendliness to developers. If you developer, and for example, I every so often try to put some application together for my personal interest. MongoDB is very easy to start, and to put a lot of unstructured, did not well thought through database. You just dump a lot of JSON unstructured documents in MongoDB, and then you try to work with it. So this is why, in my opinion, NoSQL getting popularity. But there is only so long you can go with non-structured data sets. For serious databases, you have to have structure, you have to have a relation between tables, you have to have constraints, you have to have transactions, you have to have availability, and other features. So I believe relationship databases will provide that for a long time ahead.
Thank you.
What I would like to add here, so something that was applicable, and I see that was applicable until, let's say, last year, was the CAP theorem. If we apply on the NoSQL versus SQL solution, where we have consistency, availability, and partition tolerance. Where we have consistency and availability, we used to have only relational database, Oracle, SQL Server, or any other flavor flavors like this. Tolerance with consistency, we had, for example, MongoDB or HDBase and Redis. And partition tolerance and availability, it was like Cassandra, DynamoDB, CouchDB, Rike, and so on. The things that now might make people ask themselves if one will replace the another and so on, because some of the features that we used to have only on relational database, like high availability or very strong consistency, these kind of flavors are more or less and are supported in different different NoSQL solutions. But what we need to take into account, or how I see it, that many times if we put outside cloud, and we're talking about just on-premise deployment of high availability systems, it's more easily to have maybe a relational database set up at this moment in time versus a NoSQL solution. But these kind of things start to change. So it will be pretty interesting to see if from the capturing point of view, between consistency and availability, we'll also have, I wouldn't say NoSQL solution, I would say more NoSQL solutions offered as a platform as a service from different cloud vendors. Because, for example, if you take Azure Cosmos DB as an example, and you go with strong strong session, then you have consistency, availability. You already have it. You have almost real-time replication across different regions. But of course, you have an extra cost, especially from the pricing point of view.
Okay, thank you. A long time ago, I've heard, I was on a session, probably Greg Young told this, how to break up theory. So you have partition tolerance, consistency, availability. Then you have website, you do some operations which will write data to the database. You need to write on all that nodes. And you can break this cup theorem with this cycling ring on the screen. Yeah, it will cycle while you are writing to all the nodes, and then you make a confirmation. It's like, from user perspective, it's pretty consistent. Yeah, and we're still available and tolerant to partitions. Okay, that's out of topic. And I would like to continue this out of topic. What do you think about
I would like to make a question. Could I make a question?
Okay.
We were talking about NoSQL database, and I have a question about how is this happening today? Because we have many NoSQL databases on the market, MongoDB and many other NoSQL databases in the market. But with the Cosmos DB in the cloud, Cosmos DB allows you to select the API you would like to use. So the storage and the API of access are broke down. You have the storage of Cosmos DB and you select, you can access Cosmos DB as if it is a MongoDB or as if it is many other different databases and so on. And it was planned but I think it was not released that we could change this on the fly if needed. We could change this API on the fly or accept multiple APIs to the same storage or something like that. This was mentioned by Rima on her session in 2017. So my question is, if I'm starting today a new project on a NoSQL that requires a NoSQL database, is there any reason to go to some alternative database like MongoDB and others that are usually used on premise instead of using Cosmos DB that seems way more flexible and capable of worldwide scale? Shouldn't we go directly to Cosmos DB?
Probably we always need to go to Cosmos DB. In any case, that was the idea from Microsoft. How I got it.
Yeah, Radu, what are your thoughts about that?
Depends. Yes, so this is why I said that we are seeing more and more features that until now were on relational database available on NoSQL solution. Even so, at least in this at this moment in time, if for example, if you have a tabular view where you have a lot of connection between different tables and so on, you have, I wouldn't say performance issue, but you will need to pay the extra of mapping these kind of things in a document DB way, in a document structure way, sorry. So we might see in the near future more and more close, and the gap between these two options between NoSQL and relational database, the gap will be smaller and smaller. And I think that NoSQL will gain more and more traction, especially if you put this into account with the microservice architecture pattern, where it is recommended, and it is recommended, I'm not saying that everybody is doing the same, is to have for each business domain the own database. And if we take this into account, yes, a NoSQL solution might be more preferred than the classical one. But I think that we will see on which way the market will go in just 2 or 3 years. Because still, for example, if you take Azure Cosmos DB as an example, I think that in the last 12 months, 18 months, we've seen the real heavy features that were missing to be able, by big and large organizations, to start to use it for their real, can I call it city programs, but the ones that are high load, high demand, and so on. There are still some features that are not yet available, but once we will have them available, then things might change.
But anyway, Cosmos DB looks like a very popular solution for Microsoft even
Well,
now
I would like
when it was started.
I would like to comment on that. If Cosmos DB was brought into questions, I did not want to bring to this open source against proprietary solutions, but if there has been push for Cosmos DB, I would like to push about open source databases. And fundamentally, it comes to the questions who is on control, and who is in control of data, and who is in control of your decision. And if you're under vendor lock-in, and you're free of your decision. And then if you want to be in control, I believe you have to go with open source databases. And in that case, Cosmos DB, I would not say would be a better choice. For example, as developer, I want to start my database. I want to be in control of my data. I don't want to bring anything to Microsoft in this case. And I would choose, for example, MongoDB if I go with a NoSQL solution.
Yeah, I kind of feel like I'm in a time machine here, basically. I might as well question, hey, let's all deploy on HPUX or Solaris tomorrow. Like, I've never heard of Cosmos DB. I probably will never hear of it again. I don't know anything about it. I don't think any of the proprietary databases are relevant anymore. I don't think anybody deploys brand new on Oracle anymore. Like, imagine I got a startup and I'm like, hey, I'm going to create a startup and I'm going to start with Oracle technology. Does that make any sense to anyone here? Right?
No.
Same thing with Microsoft. Like, right? I mean, am I going to start? I might start with Microsoft if I need like a departmental server and I need it really easy to install and I don't need any DBAs. I just want everything like really simple. But once you leave that space, I'm not sure Microsoft offers a whole lot. But again, I've got a Microsoft and Percona thing up on the top there, and I'm the only non-Microsoft Percona person here, so I'm outnumbered. But that's my impression of where the industry's going.
So I wonder if there will be some Radu. Maybe this is possible, but is it possible to make Postgres API to Cosmos DB someday?
Nope, we don't even care. Why would we care? Why would I want to do that?
Bruce, one important thing here that I would like to mention, and I think that after that we could close this topic because maybe we'll have other questions. What I want here to specify, Azure Cosmos DB is offering an API compatible with Cassandra API, for example, with MongoDB API and so on. What does this mean? You don't have the vendor locking. You are using the same API, the same client drivers, for example, from MongoDB, from your Java application.
Yeah, and you know why they do that? You know why they do that? They do that because they know nobody's going to write to the Microsoft API. So to be relevant, they've got to write to an open source API. Okay, but it's really just a stall tactic, very similar to Oracle. You know, Oracle years ago started buying up PeopleSoft and all the vertical applications, vertical business applications. And why did they do that? It's because they knew the database ultimately was going to be commoditized. And in the same way, Microsoft must realize that the operating system and the database is going to be commoditized. Why is Microsoft pitching Postgres for Azure? If Microsoft's technology is so great, why would they encourage people to run Postgres? Well, it's because they know there's a certain segment of the market who's just not going to do it anymore, and they realize, as Vadim said, that writing to a closed API or writing to a locked-in API just is going to end badly. It ended badly when they were on Oracle. It's probably going to end badly if they get stuck in Amazon's Aurora trap, or it's going to end badly if they almost end up anywhere. So the same reason we're not running Solaris anymore is pretty much the same reason you're not going to get a lot of traction there. There are going to be a lot of things that are going to try and offset the inevitable. I know Oracle's doing it. I'm sure Microsoft's doing it. That's okay. You know, HPUX was a great operating system, but who's deploying brand new on HPUX anymore? I don't think anybody. And it's almost the same thing with Oracle now. Nobody's really deploying brand new on there anymore because they know that is not the API that they want. That is not where they want their future to be. And, we can talk all we want about some new proprietary technology from some company, but ultimately I don't think it matters. I'm sorry to bring bad news, but that's my opinion.
Why not? Our discussion is very good now, I think. Radu? Yeah,
because I've heard, it's almost like we went 10 minutes without mentioning Microsoft's name, and we had to bring that up again. Like, I'm happy to sit here and not say anything, but if people actually care what I think, I really think, as Vadim said, that primarily, Vadim, actually, it's not only open source software, and you talked about it as well. It's community controlled software too, and that's a huge issue because what happens with Microsoft particularly is you end up sort of reading the tea leaves of where the development's going, whether it's MySQL or whether it's Microsoft SQL, or what are they going to do next? What are they going to add? What are they going to drop, right? And you're basically, as a user, sitting there completely dumbfounded to figure out what they're going to do. And you can't get involved, and you can't see what's going on. And Vadim, you have to go through all sorts of hoops even to get something that actually fixes a patch or adds a feature for them to actually care about it, right? I mean, what type of world is that, right? But that's, we're in a weird state where we're moving from proprietary everything to open source almost everything. And, databases are in this weird case because they're so sticky and they're so tied to business logic and they're so tied to custom applications that it's very hard to move out of the Microsoft realm, to move out of the Oracle realm, to move out of the IBM DB2 realm, right? But customer after user is ultimately doing that when they get the chance. And a lot of it actually is when they redeploy to go to cloud. They're like, am I going to run Oracle in the cloud? Really? Like, they make it so hard that you don't even try, unless you're on Microsoft's cloud, right? Which, as Vadim said, is kind of not going very well. So, I don't blame these companies. They had a good run and they want to maintain their users. But ultimately, and you should go to my website, I have a bunch of talks about it, you can't harness software development, and you guys have probably realized this, when you develop something as complex as a database inside of a proprietary company, it's incredibly difficult because you don't have access to your users. Testing is very hard. All the features come in through sales and marketing. And when open source development, all that kind of melts away, and you've got access to developers all the time. You've got access to users all the time. All the features are tested by the users. They're suggested by the users. I mean, I get 20 doc fixes a week just from users, right? I mean, I can't barely keep up with it. So it's just a different world, and I don't think any of the databases, even if you're as big as Oracle, you're going to ever be able to keep up with it. And if you go look at IBM supporting Postgres, Azure supporting Postgres, Amazon supporting Postgres, the only one who isn't supporting Postgres is Oracle, and I understand why. But Oracle's already given up on Solaris, and they're pushing Linux. So, what does that tell you?
So I would love to continue this discussion. Radu, Dennis, you want something to tell?
You mentioned about Microsoft supporting Postgres, and unless I'm mistaken, Microsoft has Postgres as a platform as a service. This means that you can prevent the managing of the infrastructure and use Postgres as a
Yep.
database directly. Use the Postgres as a service, and Postgres is one of the services already included in Azure Arc. It means that you
Yep.
get all these easy features to manage Postgres, and you
Yep.
can install in your own environment using Azure Arc. This
Yep.
is
And
very
it's a huge
interesting.
benefit. Yeah, huge stuff because
Yeah,
Google supports it, Amazon supports it, Azure supports it. So now you can run on technically 3 clouds with the same database, right? And that choice ability makes sure that Amazon doesn't abuse their customers, right? Because almost every database that gets their customers in a place where they can't leave, those customers get abused. And I think that is one of the key reasons I'm so excited to have Postgres support, and on Alibaba in China, and pretty much every cloud is supporting Postgres, and that's a great thing. And it's open source, it's free, so that it's no cost to them either.
yeah.
Well, one thing that maybe flavor Bruce, you are 100% correct. Again, it might be everything marketing and how to gain more from the. Even so, and it's a commodity. And here I'm not talking about a specific cloud vendor. It is at the time when you decide if you want to manage everything that is on top of infrastructure, or you would prefer to let somebody else manage the other layers with some pros and some cons. And also, the second thing that I see very important here is this part, outsourcing different layers and from the management and operation. And the second thing is the life cycle of the application of your database that you're having. If your life cycle is, let's say, 3 years and is overlapped with a specific provider of data storage, whatever type of data storage it is, and after that you have the option to get data from there and to go somewhere else, might be a good option.
Yeah. One of the things I didn't mention, and this actually gets back to something that was talked about earlier, is the concept that Postgres may not be the best place for all your data, right? We got log data, we got data that's better in Hadoop, we got data that's better in Cosmo, for example, right? So Postgres supports over 100 foreign data wrappers, which is the SQL Med standard. So effectively, you can build an architecture where you may have Postgres for some of your accounting data, but you might use Redis for some key value or comments, right? And you might use you might use Cosmo for specific types of data. And what's cool about it is you issue your query to Postgres, and Postgres knows, hey, I've got some data over here in Oracle, I got some data over here in Elasticsearch. I got some data over here in Cosmo, and I can pull that. I can issue the query. I can pull the data back into Postgres and use the analytics, use the SQL capability, the window functions, all that analytic capability of the database, and then return results. So, at the Postgres world, we don't really care if the data's in Postgres. We don't care what we interact with. So a lot of times you do see these hybrid setups where they say, I got some accounting data, but I got, images, or I've got huge amount of full text search, or I got this huge Hadoop cluster, and I need to access that data. And a lot of the commercial people don't have that interoperability because they want you to keep all your data together. They want to lock your data into their software. But Postgres, we don't care. We're not sold. So we're just open source folks. So that's why you don't have to get the Postgres API to understand Cosmo. All you need to do is write a foreign data wrapper, and all of a sudden the Cosmo data appears as a table in Postgres, and you can do that for 20 different data sources if you want. So I think, to me, that's almost the best of both worlds, because Dennis is right. There's no question that there's cases like log data doesn't really belong in Postgres unless you really want to do it. Put it in something that makes more sense, like Cassandra, and then use a foreign data wrapper to get at it when you want to. That gets kind of into that layering you were talking about.
I confess I'm very surprised with these features that you just described about Postgres. I had no idea Postgres had these features, because what you just described are features that were included in Synapse Analytics and were included in SQL Server Big Data Clusters. Both have this ability to access data from anywhere and creating a local virtual model that
Right.
applications will access this virtual model and without knowing where the data is. And
Right.
this is absolutely great for solutions like a data lake and what we are already calling as a virtual data lake. And I had no idea that Postgres had this solution as well. I'm curious now, and I will check more about and see how it compares, because it's one more
Yeah,
player
we've been
on this
developing
area.
it for probably 5 years, and it's really complicated because really, to get into the database part, you want to push as much of the query to the remote side as possible. So when we originally implemented
Okay.
it, it was a very simplistic capability of passing the request to the remote side. But when we talk about Postgres today, it's pushing the where clause, it's pushing the aggregates, it's pushing the sorting, it's even pushing the joins. If the remote side supports joins, we push the join to the remote side. So you want to push as much out as you can because you want as little data to come back so you don't have to do as much work. And because you're looking at 100 different data sources, pretty much every data source you'd ever want is going to be supported. But getting that sophistication of being able to take a query and say this sort goes there, this join goes there, this where clause goes there, that's pretty complicated. And it took us a couple years to kind of round out that full capability. But it does allow some amazing architectures, and I think we're still learning what's possible with sort of a federated database where you're looking at a whole bunch of different data sources aggregating together. And you're right, very few databases can do this kind of interoperability with other data sources.
By the way, Bruce, is this data hub part of plain Postgres, or this is an enterprise
Yes.
DB feature?
No. Everything's part of plain Postgres. Oh yeah, this is all. The only extension part, and again, it was designed in extension, is if you want to communicate to Oracle, you load the Oracle foreign data wrapper. You load the Mongo foreign data wrapper. We even have a Twitter foreign data wrapper. I don't know why, but you can read tweets from. We have a foreign data wrapper that'll go out to websites and pull data down.
Yeah, probably because
Or read the. Yeah, or read the file system or whatever, right? So there's a whole website that has all the foreign data wrappers like listed in groups and stuff. But it does, it does LDAP, it does ODBC, JDBC, the generic ones plus the specific ones. And again, a lot of people don't even think about it. They think, oh, I just want a database like my old one. And you're like, okay, we can give you that, but think of what you can do now, right? And you get some really, really interesting architectures coming out of that.
Yeah, that's really cool. By the way, Vadim, do you have something like this in the MySQL today?
Foreign data wrappers, no, it's not not really a MySQL feature. Yeah, this is where Postgres is doing much better work for integrating different data sources.
Okay. Bruce, I have a question in my list of questions. I have a question to you. What makes Postgres so trendy today? What makes it so cool? Like people wanted to use it, but probably you already answered to this question. Maybe you want to.
Yeah, I think I did. Yeah, it's a lot of it is flexibility, right? What I really said at the beginning, that extendable architecture, which when I spent the first 10 years of the Postgres, that extendable architecture was a headache to me because as you're in the database code, nothing looks like a data type. Like an integer is not an integer. It's a row in a system table that has a length and an alignment and an input function and output function. And there was a whole bunch of bugs we had originally in how it worked. And the first 10 years, it was something we really disliked about how to make it work. And there weren't many extensions at that point available. So it was this thing we were carrying but not really making use of. But probably the biggest first use was full text search, which originally was implemented as an extension. Then PostGIS came in, then the foreign data wrappers came in, then we developed the JSON capability initially, at least in prototype, as an extension. So and then we had all the new indexing types for JSON and for data warehouse, which were integrated into Postgres again because of that extendability. And I think that's why, the joke is, Postgres is not your grandfather's relational database, right? We're not the old stodgy, we only do integer and character, right? Data types. We do a lot more, and the needs of users is changing so quickly. The companies can't keep up with that. They can't, what's the new thing going on? One of the cool things about the Postgres development process is we've got people all over the world, all working independently. Normally when a company says, I'm going to go in a certain direction, everyone goes in that direction. So this is going to be our performance release. This is going to be our cloud release. This is going to be our, BI release, whatever. And they spend a year or 5 years focusing on one thing. What's weird about and nice about Postgres, which is true of almost all the community developed things like Linux, is that they've got teams operating on all directions at the same time. So I got Russians going in one direction. I got Chinese going in another, Japanese going in another, Brazilians doing something different, Germans going one way, US going one way, and you get to a release every year and you have incremental improvements in scaling, in administration, in things that DBAs care about, things that developers care about. So there's something for everyone in every release. And I think that is part of the coolness thing, that it doesn't get kind of stuck doing one thing. And that I did not realize when I started. I didn't realize that was going to be our solution. Like when I originally started with Postgres, we were just fixing bugs, right? Because it was a university project and a lot of bugs. Then we added a reliability and SQL standards. And then we added enterprise features. But about 5, 7, 8 years ago, we filled in all the enterprise features. So what are we going to do? We're going to innovate. And the bizarre part is that we can copy the SQL standard, we can copy enterprise features, but where the open source group really shines is innovation. Companies are terrible at innovating, big companies. The only way they innovate is they buy another company. And that's their innovation, right? You see it all the time. But what's great about open source is while we can copy, what we really do great is innovation. And I think that fundamentally is what makes Postgres cool, because it's that constant innovation. I mean, if you could look at my mailbox of all the stuff that people are thinking about that I'm trying to encourage, it's tremendously exciting. And as a community, we're taking thousands of people, huge. We have a brain power that no company can hire, right? Even at Oracle, I'm sure they don't have the combined brain power of our community. And you as a community member, you're taking all that brain power and you're focusing out as a lens on a single problem, right? And that's why you get these innovative solutions. That's why you get really high reliable and very powerful features. And that's why Linux and all the open source stuff works so well, and why the proprietary companies have so much trouble, because they can't really replicate that.
Thank you. That was very, very interesting. Okay, so this time we're supposed to have questions from our attendees, but I can read you these 12 questions. First question is hi. Second question, hi. I love the discussion. Hi, cool topic. Oracle PG, smile. DB panelist, hi. Hello all. Hi everyone. So that's it. I think we deal with the questions. And
We have
we
to
have 10
wave, right?
minutes. Yeah, that was easy. Okay, we have 10 minutes and let's try to answer very interesting and maybe very like complex to some degree question. What will happen with the database in the next 20 years? What new will come here and what will die in these 20 years? That will be very interesting to know from you. Who want to start? Maybe Dennis, like usual in this discussion.
It's a very difficult subject, but um, what Microsoft has of different is a complete platform that can completely build from the production to the machine learning, passing by all the steps with all Microsoft features. I think all the providers that are able to create a platform like this will live longer in the market, because it's not only more about a database. It's about uh, having the entire platform from production to BI to Azure machine learning, whatever machine learning is used, and being able to integrate this platform. Microsoft is working on the integration of this platform with Azure Synapse. So it's already on the second or third step. It has the tools, they have the tools, and now are integrating the tools on a single tool, which is Azure Synapse. The existence of this platform will make the environment survive. I'm not sure how the other databases are on this way, on this path. Uh, and Microsoft is seeing even further, because in the cloud we already have many different clouds to choose. We need to choose between Microsoft Cloud, Google Cloud, Amazon Cloud, and so on. So what
I'm not
Microsoft
sure
did?
about Google Cloud, but anyway, Dennis, I'm sorry. I've got a message from the organizer that we have each of us will have 3 minutes now to finish at 9.
Okay,
So I'm
so
not
I
I'm not
was
hurrying up you, but you know.
so concluding this part that was talking about the cloud is that Microsoft again changed the game. Where the game appeared to be set, Microsoft appeared and changed the game. Microsoft is allowing their services, Microsoft services, PaaS services to be implemented in any cloud. You can get a Microsoft SQL Server on PaaS environment to be implemented inside an Amazon cloud and control the cost and billing from all the clouds from a single point on the Microsoft environment. So it's becoming a cloud to manage clouds.
Thank you. Thank you, Dennis. Okay. Bruce, would you like to be next?
Um, yeah, I mean, I've been, when I started with Postgres, obviously we were really tiny and just we're used by people who had no money, right? Basically, who had small websites. That was kind of our bread and butter at the time. Which obviously the shocking thing is that now we're in, you know, probably half the Fortune 2000 companies. And in a way that's really eating at the traditional proprietary databases in a way that I didn't think was going to be possible. But looking back at how Linux and FreeBSD ate away the proprietary server operating systems, it's pretty much inevitable that eventually we're going to get to a point where open source and open community developed databases are really the default, and we're almost there now. It's just a question of time, I think. That everyone who's trying to be relevant and trying to stay in the development game, but I think it's going to be tough for them to sort of keep up. Whether another relational database kind of gets on the market and starts to shine, that would be interesting to see. I haven't seen anything really of that relation in the past 24 years, but it's possible.
Thank you. Thank you. Vadim?
Yeah, well, I cannot predict the future. I wish I could, but I believe trend will be toward the open source databases, and we did see I would say, escalated migration from proprietary databases to open source databases. And open source databases will be widely commoditized, and I mean that will be easy to use that developers even did not think what kind of database it is. It's like currently file system. You put files on your file system and you don't think, is it ext4, is it xfs, it is zfs, it is nfs. The same the same I think will happen with the databases. The general use of open source database.
Thank you. Thank you. Radu?
Future, I think that future is a blend. It's a blend between different types of databases and, as Bruce said, a combination between open source and proprietary ones. I think that if we would have the same discussion in 5 or 10 years, we might be almost in the same place. But I expect the difference would be that more open source solutions to be more widely used, because at least in my case, I see this also from larger organizations that are not afraid anymore by open source, and not all the time that they are required from the legal point of view to be backed by an operation and support contract by the database vendor, if we're talking about database. But the same thing is applicable for other areas. This would be all from my side.
Okay, thank you. Yeah, it would be nice to have the same discussion in 5 or 10 years. I would love to have it. And thank you very much for today's discussion. It was really great. I really loved our discussion, and it's want to say thank you that you were joined to the discussion. Thank you very much.
Thank
Right?
you.
Bye,
It
everybody.
was a pleasure to be here.
Bye. Bye, everyone.
Bye.